Okay, question 4. It's all about the law of conservation of momentum. So lana question 4. Question 4 etufundeka ngale ndlela. A trolley of mass 1.5 kilogram is held stationary at point A at the top of a frictionless track. There's no friction, so the surface is smooth all the way through. When the 1.5 kilogram trolley is released, it moves down the track. It passes point P at the bottom of the incline and collides with the stationary 2 kilogram trolley at point B. So say release isuka from A, then it slides and then it passes at the point P, and then you collide other trolley at point B. Refer to the diagram below. Ignore air resistance and rotational effect. So lana there's no friction at play, so it's a sort of like an isolated system. Won't friction, all forms of friction as we consider in such a case. All right, now 4.1, but use the principle of conservation of mechanical energy. Sikhuluma momentum la, but draw another concept, mechanical energy, but to calculate the speed of the 1.5 kilogram trolley at point P, right? Be careful again, ne? Be careful. And the statement komele sisifunde kahle. The trolley suka from A, it passes through ubani P, then you collide ubani no B. So we are only considering 2 points la, A and P. Sifuna the velocity of the trolley once it reaches ubani P, using our mechanical energy, the conservation of mechanical energy. So this is question 4. Question 4.1. I know that the mechanical energy at top will be equal to mechanical energy at bottom, and the mechanical at the top is going to be equal to the one at the bottom. Why? Because there's no loss of energy, there's no friction. We just ignore the local friction, so the mechanical energy is conserved as well. So therefore sizoba nani ne EP, asithi EP at top plus E kinetic energy at the top is equal to E potential energy at the bottom plus E K at bottom. So at the top we do have a potential energy. Why? Because we have a height at point A, no matter A or P doesn't matter. So the top part to bani A, and then the bottom part to P. So we do have a mechanical potential energy at A, but there's no kinetic energy because the trolley is being held stationary at point A. So there's zero kinetic energy. The potential energy at B at the bottom is also zero because the trolley says to get from a height all the way to a horizontal plane. So potential energy is 0 plus kinetic energy at B. We do have mobile point P at the bottom. The trolley at here move, so there's kinetic energy, and we want to calculate the speed of the trolley at P. So velocity at P nailana mechanical potential energy is what? It's mass 1,5 9,8 height it's 2 meters half 2 1,5, that's mass. Velocity sifuna yona squared la. So let's multiply 1,5 times 9,8 times 2 is 29,4 equal to 0,5 times 1,5 is equal to 0,75. Lona 1,5 mass v squared. Let's divide 7,5 then uv 29,4 divided by 0,75 is equal to 39,2. Square up both sides again. Square up both sides. 39,2. The square root of 39,2 is equal to 6, is it 100? Yes, 6,26 meters per second. This is our velocity. This is our velocity at the bottom of the incline, or at point P. So this is our velocity for a trolley. Now 4.2. Now 4.2, but when the two trolleys collide, they stick together and continue moving with a constant velocity. To go 4.2, but the principle of conservation of linear momentum is given by the incomplete statement below. In a or n system, the linear momentum is conserved, right? Siyazi ke ukuthi lana kumele ngene ubani. In order for momentum to be conserved, we need an isolated system. So in an isolated system, the total, just like you go conservation of mechanical energy, the total energy before is equal to the total energy after in an isolated system. So nalana, in an isolated system, the total linear momentum is conserved. So you need to rewrite the statement, rewrite the complete statement and fill in the missing phrases. Mina lana ngeke ngisirewrite. I'll just say in an isolated system, the total lapha kwesinye space kufuneka ngene ubani the total. So isolated system, the total linear momentum is conserved. That's our answer now. In other words, bafuna ukuthi nedi ustate the law or the principle when I just like they did half of the work when I just need to fill in the words to complete the remaining work. 4.3, calculate the speed of the combined trolleys immediately after the collision. Immediately after the collision. So siyazi ukuthi lama trolley ayenzani, ayo-sticker together. So the conservation of linear momentum. P initial is equal to the sum of P final. So initially mass acity. Okay, so no trolley, right? Okay, acity again. Acity, this is mass 1 representer. Trolley 1 trolley in a mass yaga 1.5, and then 2 is a representer, the trolley with the mass of 2. So this is the initial velocity for trolley 1 plus mass for 2, which is trolley in 2 kilograms. So initial velocity for trolley 2 is equal to, since lama trolley ayo sticker together after the collision, it means no mass for trolley 1, no mass for trolley 2 bazoba combined, and their velocity is over common. So let's write it like this. Velocity is over common for both masses. So this is the final velocity and over common for both, right? Let's choose to the right as positive. This is momentum collision. There's a collision to the right as positive. So literally 1 lena izomove ngale velocity esiqeda ukuyicalculate la ku 4.1, which is to the right, and to the right is positive. So initially we have 1,5 lana. The initial velocity is about plus 6,26 plus mass 2, it's 2 kilogram. Initial velocity for trolley number 2. Trolley number 2 stationary at point B, so it's 0 equal to mass, it's 1,5 plus 2 sifuna final velocity of both combined trolleys. So 1,5 times 6,26, answer is 9,39. Lana it's 0, so any number. 1,5 plus 2, it's 3,5 V F, divide both sides with 3,5 final velocity is equal to 9,39 divided by 3,5. Answer in 2 decimal places is 2,68 meters per second. Right to the is over to the right ngoba le trolley lena yo collider nale trolley emile lapha ku point B ayo sticker together, meaning azomove to the right. That's why answer it positive la ngoba to the right is positive. Now for 4.4, which is the last question for this question, but to calculate the distance traveled by the combined trolleys in 3 seconds after the collision. Here's the question. Okay, again, velocity is calculated as change in x divided by change in t, right? The distance traveled by the combined trolleys in 3 seconds after the collision. So 9 days owenzeka trolley A, trolley 1 and trolley 2 nabaqeda ukushayisana bazohamba boy 2 to the right ngani with a velocity of 2,68 meters per second to the right. Nabaqeda ukucollide for 1, 2, 3 seconds. Sifuna ukwazi ukuthi ba travel i-distance engakanani for 1, 2, 3 seconds. 2, 3 seconds. So lana it took them 3 seconds to move from this point to this point. Sifuna ukwazi ukuthi what's the covered distance. Sensing in a velocity and the time, I can calculate the distance using this formula. So in your cross multiplier, delta x is equal to v times delta t. The velocity is 2,68 times time, which is 3 seconds. Our answer is equal to 2,68 times 3 is equal to 8,04 meters. This is the distance in that direction. So our video is ophelela lana. In the description below uzothola ama links for amanye ama questions akhona kule question paper lena. Nangabe uyenjoyile this video ungakhohlwa ukuyilike. Nangabe new to this channel, please consider subscribing. Thanks for watching, guys, and thanks for all the support, the love. Ngiyawabona ama comments wenu lapha. I appreciate it, guys. Thanks for watching and continue watching, please. Ungakhohlwa nokushare le video le or this whole question paper lena uyishare nomunye umngane wakho so that naye azokwazi ukuthola some information, akwazi understand better some of the topics. Ngoba whenever I answer a question, I try to break it down as far as possible, right? So yeah, thanks for watching. Asibonane kule video elandelayo. Peace.